All right, class, we are starting our next lecture. This is, I believe, this is 4.1b. The essential standard is I understand polynomial terminology. That has to do with term, coefficient, and degree. I can add, subtract, multiply, and divide using synthetic or long division polynomial expressions. We are going to save our divide lecture for another day. A monomial is a number, variable, or single term that is the product of one or more variables with non-negative integer exponents, excuse me. So they have to be non-negative integer exponents. Polynomials are one or more monomials combined with an addition or a subtraction. The degree of the polynomial in one variable is the largest exponent. So if you only have one variable, the degree of that polynomial is the largest exponent. The degree of a multivariable polynomial is the largest sum of the exponents of a single term. We are only going to be dealing most primarily with single variable polynomials at this time. So that last statement won't come into play. But let's talk about what the terms are. Each one of these is a term, so they are separated by addition or subtraction. That this particular in A has three terms. Now what we need to ask ourselves, is this a polynomial or not? And if it will be, if each one of these terms is a monomial. And we have to look at our rule for monomials. This x is to the power of 1, which is a non-negative integer. However, the second term is to a power of 1/2. Square root of x is the same as x to the 1/2. That 1/2 is not an integer exponent. It is a fractional exponent. So this is not considered. The answer here is no, because x to the 1/2 has an integer. Well, we could say because, x to the 1/2 has a non-negative integer exponent. That 1/2 is a fractional. It is not an integer. Okay, what about this one in B? Well, that is the same as 2 times x to the -1 plus 3. So this is no, because in the 2x to the -1 term, the -1 is a is not a non-negative integer, okay, because it has to be a non-negative integer, and it is negative, so that is not a polynomial. All right, so what about this one? Try C and D yourself. Welcome back. So if we look at C, we see that we have x to the 3rd power. This is the same as x to the 1, and technically this is the same as x to the 0 power. And those are all integers, so this is yes. And they're all non-negative. How about the next one? I have x squared, I have x to the 1st power, and I have a -1. And so we can say no, -1 is not a non-negative integer. Okay. All right, moving on. We want to simplify the polynomial expression. We're now adding and subtracting polynomials. So what this means is that I need to add this entire polynomial to the second polynomial. Okay. And since it's addition, I can just add all of the like terms. So I have x squared plus 3x squared, and that will give me 4x squared. I have 3x minus an x, and that will give me positive 2x. I have two constants, And that 11 minus 2 will give me 9. And there is the answer, 4x squared plus 2x plus 9. Try one yourself. All right, welcome back. I have 2x cubed terms, and 8 plus 2 will give me 10x cubed. I have only one x squared term, so I have plus 3x squared. I only have I have only one x term, so that'll give me plus x, and I have two constants, and I add those constants together. -4 minus 7 is -11. So our answer is 10x cubed plus 3x squared plus x minus 11. All right, moving on. In C, I am now subtracting polynomials, and we have to be very careful because this subtraction means that this entire polynomial is subtracted from the first polynomial. So we have to distribute that negative through this expression. So you could rewrite that as x squared minus 5x plus 6 minus 2x squared minus 3x and then plus 1. Now we can combine like terms. I have 4x. How about we just highlight them here? I have two x terms and I have two constants. All right, so the 4x minus 2x squared will give me 2x squared. Negative 5x minus 3x will give me negative 8x. Now I can combine my constants. 6 plus 1 will give me plus 7, and this is the answer. Okay, how about try one yourself? Welcome back. Once again, this negative has to be distributed through the entire polynomial. We want to subtract this entire polynomial from the first polynomial. So you could rewrite that if you wanted to. That's a cubed minus 7x plus 8 plus 3x squared minus x minus 3. Then we're going to combine terms. I have only one x cubed term. I have how many single x's? I have 2. I left off my x squared. Let's redo that. How about my x squared term? There's only one of them. And then I have a constant that I need to add. So 6x cubed is the only term that has x cubed in it. Then I combine my x squared terms. There's only one, that's 3x squared, so plus 3x squared. I have negative 7x minus 8x will give me a negative 8x. And then I have two constants, 8 minus 3, which will give me a positive 5. Okay, moving on. Now we are going to do multiplication. And so what we have here in A is that I have 3x, and it is essentially going to be multiplied by everything. It is essentially multiplying each term within the polynomial. So I have to essentially multiply each term by 3x. So when I multiply 3x times 2x squared, I have to use my rules for exponents, and I will get 6x cubed. I have to add the exponents together. Then I will get minus 12x squared, and 3x plus 6 will give me 18x. And why don't you try one yourself? Welcome back. I have to multiply negative 2a through the entire polynomial expression. And when I do that, I will get 6a cubed, and then negative 2a times minus 11a will give me positive 22a squared, and then negative 2a times positive 20 will give me negative 40a. And that is the answer. Okay, C. For C, I now have two polynomials that are multiplied by each other. I have to multiply each term in the second polynomial by the n. I have to also then multiply each term in the second polynomial by the 2. And so if I do that, I will get n cubed plus 4n squared minus 6n. And then when I multiply through by 2, I will get 2n squared plus 8n minus 12. Notice how I've kind of organized it in a way that I can quickly add my like terms. So if I look at them, I have now n cubed plus 6n squared. Negative 6 plus 8 gives me a positive 2n minus 12, and that is the answer. Here's another neat way to do this. You can actually use kind of like a geometric approach. I have 3 terms, so let's see. First one, n squared 4n minus 6, that came from the second polynomial. That was the terms in the second polynomial. And then n and 2 are the terms in the first polynomial. And this box is going to represent what I would get if I multiplied n times n squared. And so I would go through and fill those boxes in for each one. This would give me n cubed. This would give me 4n squared. This would give me minus 6n. This is 2n squared. This is 8n, and this would give me negative 12. Now I can combine terms. This is the only n cubed, and this is the only constant. And so you can do it this way if you would like to organize your terms in that manner. So 2n squared plus 4n squared gives me 6n squared. 8n minus 6n gives me 2n, and then I have negative 12 by itself. Same answer, different way, whichever one you like. It's kind of an easier way to organize your work. All right, try one yourself. Welcome back. Essentially, we need to multiply every term in the first polynomial by every term in the second polynomial. So we're going to multiply x squared through the second polynomial. Then I'm going to multiply 4x by the second polynomial. Then I'm going to multiply 16 through the second polynomial. And if I do that, x squared times x gives me x cubed, and then I'll get minus 4x squared. Then I will get a positive 4x squared and minus 16x. And if I take the last term, which is 16, I will get 16x and minus 64. That's what I meant to say. So 16 times negative 4 is 64. Now I need to add all my like terms, and so I have only one x cubed. My x squared terms cancel, my x terms cancel, and I have one constant, which is negative 64, and there would be my answer. All right, moving on. I essentially am going to multiply each term in the second polynomial by x, and then I'm going to multiply each term in the second polynomial by negative y. So what will I get? I get x cubed plus 2x squared y plus xy squared. And then if I multiply through by y, or negative y, excuse me, don't forget that negative, I will get a minus x squared y minus a 2xy squared minus a y cubed. Now I need to combine like terms, and I only have one x cubed term. Negative 2x squared y minus x squared y gives me a positive x squared y. So let's just talk about that for a minute. This has a coefficient of 2 and a coefficient of negative 1, and these are the same. These are the same terms, okay? So we can combine them, okay? So don't be confused if there's multiple variables. As long as the exponents are identical, then you can combine them, okay? So I have, to continue on, I have a positive xy squared minus a 2xy squared, which will give me a minus xy squared. And then the last term will be negative y cubed. All right, let's try one yourself. I'm essentially going to multiply through the entire expression by x minus x to the negative 2. And we'll use our exponent rules. And so I will combine, if I multiply x to the negative 2 times x to the 4th, I have to add those exponents. So 4 plus a negative 2 will give me x squared. And then I will have x cubed, and I will have 3 plus a negative 2, which will give me 3x. And then I have x to the negative 2 times x to the negative 1. Negative 2 plus a negative 1 will give me x to the negative 3. This is an acceptable answer. You could also write it as you could change that last term to 1 over x cubed to get rid of the negative. Either one is acceptable. All right, you will see this show up on your SAT. So why don't you try, there's 3 of them. Go ahead and try your 3 SAT practice problems. Welcome back. So the first one is, which of the following is equivalent to the expression above? And so in order to do that, I need to, whoops, wrong one. I need to distribute this negative through the entire expression and rewrite the expression. So now that will give me a positive x squared y minus 3xy squared plus 3y squared. Now I've got to go find all my like terms. So the first one is x squared to the y, and sure enough, I have another x squared to the y term. The second term I notice has a y squared. Do I have any more y squareds? Yes, I do. I have one here. What about xy squared? Sure enough, I have one here. So let's combine them all together. So x squared y, has a coefficient of 1, and I have another one that has a coefficient of 1. So if I add them together, I will have 2x squared y. And then I have a y squared term. It has a coefficient of -3, and I have another one with a positive 3, so it will cancel each other out. Then I can look and see that I have a coefficient of 5 for my xy squared. I have a -3, so I'm going to say 5 minus 3 will give me 2xy squared. And I have what seems to be the problem here. I've already combined those. So that is the answer, actually. And there it is, 2x squared y plus 2xy squared. Okay, moving on. If in the equation above, A, B, and C are constants, if the equation is true, that means that those two sides are equal to one another. For all values of x, what is the value of b? So you have 2 ways to approach this. You can just notice that b is on the linear term, okay? So it is only on the term that has x to the 1 power. And you could then look at each one of these and think about, okay, which ones are my linear term. So look, I have 2x times 3, 2x times 3x is an x squared term, so I don't really care about that. What about 2x times 5? That gives me 10x. That is a term that I'm interested in. Now I have to move to the next one. So this gives me 3 times 3x. That is also a linear term, and that would give me 9x. The next one is 3 times 5. That's 15, so I'm not really interested in that. And so that would give me 19x. So we know that the value of b would be 19. Now, the other way you could have done this is you could have actually just went ahead and multiplied each one of these out. So you could have done the work and said, okay, 2x times 3x is 6x squared plus excuse me, 2x times 5 is 10x. Then I would have 9x. Then I would have 15. Then I could have simplified this. And once again, we can see that the b term is 19. This approach up here is a little bit faster, but either way would work. All right, moving on to the next one. The sum of negative 2x squared plus x plus 31 and 3x squared plus 7x minus 8 can be written in the form of ax squared plus bx plus c, where a, b, and c are constants. What is the value of the constants a plus b plus c? So essentially, it says sum, so we need to add them together. So we're going to combine the x squared term. So if I have minus 2x squared plus 3x gives me x squared. Then I'm going to combine the x terms. That gives me 8x. Then I'm going to combine my constants. So positive 31 minus 8 gives me plus 23. Okay. And so now we know that A is equal to 1, B is equal to 8, and C is equal to 23. Those added together will give me 8 plus 1 is 9. 9 plus 23 is 32. All right, that concludes our lesson for the day. As always, reach out to me if you have any questions.